background some background papers before I get into my paper. PRC is shown an image on an LCD screen. And when that image was of either a toy or an egg. And when that image was removed, they then put that same image and whatever object they did not choose right next to each other, the toy and the egg. And the rat had to choose between the two. If the rat chose the object that they had been shown previously, then they got a reward. If they chose the wrong object, they did not get a reward. Yes?
Can you do that one more time, please?
Okay. The rats were shown the image of an object, either a toy or an egg. And then that image was taken away. And the toy and the egg were placed next to each other. And the rat had to choose between the two objects and choose the object they had been shown previously. And if they chose the right object, the object they had been shown, they got a reward. And if they didn't choose the right object, they did not get a reward. Yes?
Why did they choose an object? Was there any incentive,
before any data was gathered, they were behaviorally conditioned to do this for 4 days.
Okay.
And that reward system kind of just got them motivated, I guess.
Avni.
Yes.
And this is just regular rats. They haven't done anything to their PRC.
No, these are wild type rats. Yes.
Can you quickly explain what spatial memory is versus not spatial memory?
Spatial memory is, from what I understand, just the processing of the information around you based on other senses other than visual perception. I could be wrong about that, but I think that's what it is. Yes?
So the first images were on a screen and the second was the physical object. So
No. All of it was on an LCD
okay.
screen. So when they had to choose between the objects, they had to either click left or click right on a mouse pad.
So those would both be PCR memory.
Sorry, go ahead.
So those would both be PCR, or PCR?
PRC.
Right, PRC memory storage? Because it's visual.
In essence, yeah.
Okay.
Go ahead.
How often was the rat correct, or was it successful?
I'll get to that. Yeah?
Were they surrounded by other mice who were doing a similar activity, i.e. if they saw another mouse choose the right object, that they saw the other mouse also saw?
No, I think they were in isolated environments. Okay. So the next part of the behavioral study was the ambiguous sessions, where they took the toy and the egg and they morphed it into 10 different images, each with different levels of morphology. And we explain this as different levels of ambiguity. So the rats were then shown one of these morphed objects. That image was taken away, and they then had to, and the toy and the egg were then put on the screen. And they had to choose which image it looked more like. They had to categorize the image they were shown as either the toy or the egg. And if they were given one of these 5 and they chose the toy, they got a reward. If they incorrectly categorized it, they did not get a reward. So in essence, the same reward system. Yes?
What was the reward?
I assume it was a food. Yeah, I'm pretty sure it was a food. So how do you think the performance of standard versus ambiguous sessions were different? After seeing these 2 different behavioral studies, do you think the rats performed better when having to choose between 2 or having to categorize? Anyone? You don't know how to answer.
Oh.
Here.
you.
Good job, you got it. The results of the session showed that rats performed worse during the ambiguous sessions than in the standard sessions, with the rats performing over 80% correctly, choosing the correct object 80% of the time during the standard sessions, and almost 70% of the time with the ambiguous sessions. And another result of the study showed that as ambiguity of the object increased, as the toy and the egg morphed together more, the performance of the rats decreased. And this kind of just established a baseline in which now they can compare PRC activity to these results. So the next experiment they did, yes?
Can you go back a slide for a second?
Yeah.
I'm noticing that on the graph B, the ambiguity 0 test, they did significantly better than they did with similar images on the first one, the non-ambiguous one.
Yeah, I'm not quite sure why. I think it's just luck of the draw, maybe. It's probably not incredibly significant.
Okay.
Wait, what was A?
A was the standard versus the ambiguous sessions as a whole.
Oh.
And that's just as ambiguity increased. Yes?
Were they done on different sets of rats? Like the one with the morphed objects versus one with just the egg and the toy?
I believe so, yes. But they were still behaviorally conditioned the same way. So the next experiment they did was specifically looking at the PRC activity. They had two chemicals in which they injected into two different groups of rats. Sol, which causes the PRC to glow, but it doesn't affect PRC activity at all. And then they injected mus into another group of rats that causes the PRC activity significantly. Decrease significantly. Like the Sol rats, with no effect to the PRC, performed almost equally to the original baseline standard sessions, and the mus significantly decreased. And this is just an image of the PRC lit up by a mus injection. Any questions? So if the PRC is inactivated, how would it affect rat performance? Anyone? I heard a bunch of mumbling, but yeah, it would significantly decrease rat performance. This graph is not incredibly important, but the scientists wanted to establish a baseline firing rates for all of the neurons involved in the PRC activity. All of the neurons in this graph have been taken from different parts of the PRC. So now to kind of review how they divided the standard session structure, they divided it into two periods, the pre-choice period and the post-choice period. And this is important because they then compared the baseline firing rates to the firing rates during those two periods. So, as you can see in graph A, some of the neurons significantly changed their activity, their PRC brain activity, in only the pre-choice period. So that's from when they were shown the object to right before they made the choice. And in graph B, you can see that some significantly changed their brain activity in the PRC in only the post-choice period. But most showed change in their firing rates in both the pre-choice and the post-choice period. And this shows that the response to the choice, the rat's response to the choice, affects activity in the PRC, which shows that it's not just object recognition that affects activity in the PRC.
Could you do that again?
Okay. So the scientists split up the standard sessions, as I showed before, into two different periods. The pre-choice period, from object sampling to the choice response, to post-choice period, to the post-choice period, from choice response to the reward system. So, as I said before, they established a baseline firing rates for all the neurons involved. This was just like everyday activity, just how the PRC fired in an everyday situation. And then they compared the firing rate activity while the rats were making these choices to this baseline firing rates, these baseline firing rates. So some of the neurons only changed activity in their pre-choice period, as shown in graph A, and some only changed their activity in the post-choice period, as shown in graph B. But the majority of the neurons involved in the PRC changed their brain activity and their firing rates in both the pre-choice and the post-choice period. Yes?
Do you have like numerical values for the number of mice from each category?
I don't. Sorry.
Like, I just don't.
I think it's like 50 for each. Yes?
So what's the difference between A, B, and C? They're all different neurons?
Yeah, they're all
measuring different neurons.
Yeah, they're, because in here you can see that there's a bunch of different neurons kind of in this whole bunch of neurons from the PRC. And some of them responded differently to making that choice. Yes?
So how are they measuring it? Are they doing it with, are they doing it just by fluorescence?
No, I think they're doing it,
Or are they measuring it like electrically?
I think they're doing it electrically.
Yeah, it says it's in hertz.
What's that?
HC.
Yeah, I think it's electrophoresis, something.
The unit is in hertz.
Oh, okay.
Okay. So this is just, sorry to like reestablish my point. This is important because it shows that the choice response, not just object recognition and the reward system, the actual choice response causes activity in the PRC. And the final thing they looked at was to see what part of the choice at the final post-choice period causes the change in activity. So they checked the PRC activity through making from the choice response to the reward system, and they saw that the PRC activity spike was directly after the choice was made. So the outcome of the choice affects PRC activity as well. As you can see here, the most significant spike in firing rate was right directly after the choice was made at 0 seconds. Any questions? Yeah?
So just to clarify, you're saying that the greatest amount of PRC activity was when they made their choice?
Yes. Yes.
Yeah. Is that because, or do they know why that spike happened? Do they like store in memory of what happened during choice?
Storage or recall?
Yeah.
Yeah.
I'm not completely sure. I think that's something they have to go into further depth study. I think they were just trying to establish that there's a link between the outcome of the choice and PRC activity. Any other questions? Yes?
Did they find a relationship between the height of the PRC spike and the choice made between the egg and the toy?
I don't think they went into much depth with that. Yes?
How are they measuring the second?
Oh, this is just to show that it wasn't the reward system that had the most significant spike. It was the choice response.
So like 0 seconds is the choice, and before that's like the spike.
I believe this is split up with the post-choice period. Sorry, pre-choice period and the post-choice period. They kind of had the object image drifting off, but the significant spike was at the choice outcome, like when they made the choice. And the there was another spike at
Drew Browdy, please go to the nurse's office.
There was another spike when reward system happened, but it wasn't like very significant.
So does 0 represent right when they make a choice?
Yes.
What's the mini green peak under them?
I don't think it's significant, but it's just like I assume as the rewards for PRC activity. Any other questions? Okay. So some conclusions to draw from this paper would be that that PRC activity is activated by object recognition memory as they expect it to happen and as was established by the Sal and Musk experiment. That choice response also affects PRC activity, which is incredibly cool because they didn't know there was any link between choice response and the PRC before. And the third, sort of variable that affects PRC activity would be the outcome of the choice as established by the previous slide. And it's just kind of cool because they show that information that comes from different pieces of the brain affects activity in the PRC. So there's lots of different variables to the PRC, not just what was originally expected to be processed by the PRC. It's not just visual perception and object recognition, but also spatial memory and different information that never really had been established to be processed, by the PRC. And this could also lead to other possible direct physical links to the PRC, like the connection that the POR and the PRC had been discovered before. So some next steps could be possibly to figure out if there are certain drugs that inhibit the activity of the PRC caused by one of these different variables. And another question that could be asked in like a long, long time, because if somebody was brain damaged, could that, like in any part of the brain, could that affect your ability to make a visual choice? Because if some information couldn't reach the PRC and couldn't cause their activity, were you in your full faculties to make that choice that you made? And of course, there needs to be more additional studies made. There are additional studies that are needed, and they could look into, as I mentioned before, links possibly to the POR or different sections of the brain that could be connected to the PRC, all having to do with just memory. Any questions? Yes?
Well, I'm going back to like PRC firing after you make a choice. What neurons are more active, like when the rat's just shown the head?
Repeat that, sorry.
So you know how in the experiment they're showing this image of like a tiger and a boy, and then they have to pick after.
Yes.
And after they're given a choice, the PRC makes neurons fire.
Yes.
What fires like after showing this picture?
I think there were a few neurons that did fire right after the pre-choice, but that link had already been established by, by Sal and Musk. They established that there was a link between recognizing that object and PRC activity. Does that answer your question? Sort of? Anyone else?
What part of the experiment are you saying implies that PRC has a correlation with like spatial activities? Which part?
Choice outcome doesn't have anything to do with visual perception or object recognition. Choice outcome has to do with information processed about one's environment, the results of a choice. And that has to do with spatial memory.
So choice outcome, just to be clear, isn't like right after you made the choice. Can you explain what choice outcome is again? Sorry.
Choice outcome is, it's directly after you make the choice. The spike in like, I don't want to make too many assumptions because I don't fully understand it, but what I understand it to be is that spike shows that PRC is activating after recording information about the results of that choice, I guess. Sorry, I know that wasn't very eloquent. Yes?
So are you saying that they're seeing the image like from -2 to 0, and then on 0 they make the choice, or is it on 0 they see the picture and then they make the choice?
I think the image was shown before the -2. I think that.
So 0 is like when they choose.
When they choose between the toy or the egg, or categorize.
Okay, so then you're saying like with the spike being right after the choice, like we don't really know if that's technically recall because recall would have happened before the choice.
Yeah.
So the rat is getting rewarded after they're making the choice.
Yeah, but this shows that from peak firing to food tray, they don't get the reward until after that spike has already happened, so that doesn't have an effect on the peak of their firing after the choice.
Right, so like when they're making a choice, it's not based on reward. The reward is derived after the choice.
Yeah.
Oh, that's cool. Does everybody get that? No?
Yeah.
Does anybody get that?
Isn't that spike a result of the fact that they got reward from previous choices?
I'm sorry, I can't hear you.
Did that spike, is when they make that choice, did that spike the fact that they had a reward from previous choices? Because when it was just like,
I mean, I don't really know the specifics of it, but I think since they have been behaviorally conditioned to expect that reward if they get it right, then maybe it has some effect on it, but I don't think it's significant. Yeah?
Did they see the spike in both incorrect choices as well as correct? Or does that?
So they did have some data on incorrect versus correct, and I think the only significant thing about it, no? Okay. The only significant thing about it was to show that it wasn't, that there was still that spike in choice outcome even if they didn't get the reward.
Yeah.